Good morning. This lesson is going to focus on segments, and more specifically, segments within parallelograms. So this first example is about the idea that opposite sides of a parallelogram are congruent. So when we study our diagram closer, and I'm going to zoom in a little bit, you can see that we've got three labels, but we are really going to focus on the set of opposites. So we are going to work with the expressions 6x minus 12 and 4x plus 6. What I just wrote in purple is a set of congruence marks. Now if I look at my other set of sides, I don't have enough information to build an equation because there is no expression labeled here. So I'm specifically choosing this set because I have two different algebraic expressions to work with. So again, as I said, we're going to be building an equation that is part equals part because the segments, the sides that are opposite are congruent. I like my larger variable on the left, helps me with my algebra. And then I'm going to work through my solving steps. Remember, as I solve, my answer that I get for x is helpful anywhere within this diagram. So I could actually substitute it into all three expressions if I wanted to. I could work on getting the perimeter. That is a little bit more than I can get within one video. So I will just follow the example I created and show that x is 9. I pause to switch the papers. Just working a little bit here to get the focus in. Sorry for the delay there. This shows a new statement about a relationship. The diagonals of a parallelogram bisect each other. Bisect means that we create a midpoint. So looking closer at this example, I is a midpoint, and it is a midpoint in two directions. It is a midpoint for segment EG, and it is also a midpoint for segment FH. We can put in some congruent marks to remind ourselves that it's a midpoint. And I'm going to write that vocabulary word there to emphasize it as well. Building our equation, we are going to work with the format part equals part, and we're going to focus, uncoordinated teacher there. We are going to focus on this longer diagonal, because we have two expressions labeled on it. Slide over here so you can see my work. Again, I prefer the larger x term on the left. And working through my solving steps. X is 6. And please remember, this could be substituted anywhere within this diagram if I wanted to look at specific lengths within the parallelogram. Third and final example for this video. This example is still focusing on the diagonals, but please watch because we have a part and a whole. And I tried to use that yellow to emphasize that 7x plus 10 is representing the entire length of diagonal MK. We saw this earlier in the semester, and what we did is we used a copying strategy because the two parts are equal to each other. So the first thing that we're going to do is we're going to do some copying because we have congruent parts. And then down here, we're going to do a part plus part equals, I'll write in orange instead of yellow because yellow is a little bright. Whole. Just underline that so you know it's the yellow. I'm not sure how much the colors help on the camera, but I will post the notes so it may be helpful if you look at the images. So the first part is x plus 15. We copied that, so we have another x plus 15. And the yellow arrowheads in the diagram were to emphasize that 7x plus 10 is the whole. Please remember you understood ones when you combine like terms. I don't think I'm going to color code from here, so I'll just switch to finishing out in one color. A couple more solving steps to determine what x is. Ooh. X is 4. Again, please remember that 4 could be substituted anywhere within the picture. If you do that mentally, the two smaller segments are 19 units, and the entire diagonal MK, is 38 units. Good luck with your work today. Miss you guys. Be well.